this point, and the key for that is you always have to draw the Lewis structure. So you have just guessing. And I like to teach the concept of the steric number, which is basically summing up all the things that you have to fit around from the central atom. Okay, so that is coming from the Lewis structure. Those things are either other bonded atoms, okay, or they could be lone pairs that are on the central atom. So it's the number of bonded atoms, doesn't matter if it's double, triple, single bonds, whatever, plus the number of lone pairs of the central atom, okay? So you're just adding together how many things you have to fit in three-dimensional space around your central atom. Okay? And then your steric number is going to directly correlate to your electron group geometry. So steric number of 2, your electron group geometry, or your parent geometry if you like, is just linear. Steric number of 3, that electron group geometry is triple planar. Steric number of 4, your electron group geometry is going to be tetrahedral. And these are all just coming from simple three-dimensional geometries, right? And then steric number of 5 is trigonal bipyramidal. So that is 2 triangular-based pyramids base to base. And then the last one you need to know, Jake, is steric number of 6, which is the octahedral electron group geometry. So from those electron group geometries, your ideal bond angle is coming straight out of that geometry, okay? So your ideal angle for linear, if you divide 360 degrees by 2, you get 180 degrees. Trigonal planar, you divide 360 degrees by 3, you get 120 degrees. Tetrahedral, fully three-dimensional. So the vertices of a tetrahedron are 2 opposite corners of the top and bottom edges of a cube. So those angles are about 109.5 degrees. Trigonal bipyramidal has 2 angles, okay, between the equatorial and axial positions, so that's a 90-degree angle, and then around the middle between those equatorial positions is essentially a trigonal planar shape, so you also have a 120-degree bond angle there as well. And octahedral all bond angles are 90 degrees, fully symmetrical. So where we see deviations from those ideal bond angles is when your steric number, one of those electron groups, or more than one of those electron groups, is a lone pair of electrons. Because a lone pair of electrons in the central atom is not bonded to a second atom, therefore there isn't a second nucleus coming in to like mitigate that big area of negative charge. So the lone pair is going to repel more than bonding pairs of electrons that are shared between 2 nuclei. So just remember, lone pair repulsions are the biggest, and then technically a triple bond would repel more than a double bond, which would repel more than a single bond, just because there's more electrons in that area of three-dimensional space. So now, if I can actually find the right button on my keyboard, there we go, we can answer the question. So remember, for any of these problems that's talking about VSEPR or valence bond, orbital hybridization, anything like that, you have to draw the Lewis structure first. You're not going to get away from that. So first things first, just going to remind you that the valence electrons for each group in the periodic table then is going to be group 1, group 2, and then skip across to group 13, 3, 4, 5, 6, 7, 8, something a bit like that. All right, so you get the idea. So if we've got the iodite ion, we are going to need to add together. Iodine is 7 valence electrons plus 2 lots of 6 from the oxygen, and because there is a -1 charge, for a minus charge, we are going to have to add another electron from that -1 charge. So 12 plus 7, 19, 20 valence electrons. Draw your Lewis structure. So let's put oxygen, iodine, oxygen. So I know it's boring, right? You've got to do the Lewis structure first. I know a lot of people will try and skip that step, but then the trouble is what you're essentially doing at that point is guessing, because you don't know if there are lone pairs on the central atom or not, so you're guessing the shape. Okay, so then we're going to fill up the oxygen with lone pairs like so. And then we're going to have a quick count up and see if we're at 20 or not. And I've been a bit naughty because this isn't iron and you're supposed to put ions in square brackets to the charge, so I should do that as well. Let's see while we're at it. 1 square bracket, kind of sort of. 1 minus 1 charge. Now we have a polyatomic ion. Okay, so what have we got? 2, 4, 6, 12, 14, 16 valence electrons. Okay, so we are short valence electrons. We're going to have to add some more to the central atom. So 18, 20, we've got the right number of valence electrons, and iodine has a complete octet. So we're pretty happy that that is our Lewis structure. So steric number, then 2 bonded atoms, because there's 2 iodine-oxygen bonds, and there are 2 lone pairs of electrons on the iodine, giving us a steric number of 4. Therefore, our electron group geometry is tetrahedral. Therefore, our ideal bond angle is going to be 109.5 degrees. However, if I was to actually draw this, and I'm going to take the easy option here of having the oxygen atoms being the in plane ones, and then my lone pairs are going to be the dash and wedge. So one lone pair of electrons is going to be sticking out at me towards the screen, and the other lone pair is going to be sticking behind me. So lone pair over here, lone pair over there. They do take up space in 3 dimensions. Let's just get like a wiggly line like this. So the way I often show it is I'll just draw a kind of blob around it to be like, hey, these are taking up space. So the ideal bond angle between the oxygen, iodine, and oxygen would be 109.5, but these lone pairs are actually going to take up more space than the bonded atoms, so they're going to squeeze these 2 oxygen atoms closer together. So that bond angle should actually be slightly less than 109.5. So to answer the questions, the central atom was iodine. There are 2 lone pairs around the central atom. The ideal bond angle will be 109.5, but the actual bond angle should be smaller than 109.5. Or if you prefer, you can just use a less sign. I think Alex just wants you to select smaller. Okay.